Alright, now we're going to start talking about transformations, like reflections and stuff. So this is card 132, and here's the first thing we need to know. A reflection over a line and that's any line, but let's say line K for this example. And that notation would be R, K, like that, is a transformation in which each point of the original figure and the other word for original figure is pre-image, has an image that is the same distance from the line of reflection as the original point but is on the opposite side of the line. Remember that a reflection is a flip. Let's see. Actually, I want to make a quick change here. That should really go on its own line because that's an important statement. And then we can say, under a reflection, the figure does not change size. Okay. And one more little thing we can write is that the line of reflection is the perpendicular bisector of the segment joining every point and its image. Okay, so a reflection in the line K of triangle ABC equals triangle A prime actually, erase that. Let's put that on the other side. Okay. Alright, let's flip this. Okay, so let's draw a triangle. And let's call this one the pre-image. So this is the original. So we'll just call it A, B, C. Right? Then we have a line of reflection. Let's call it K. Alright. And so what we do is we go perpendicularly. So I'm about 1.9 centimeters away. So I go 1.9 centimeters on the other side. Let's actually make that a dashed line. And I do the same thing for the other ones, but I go the correct distance away from the line. So, for example, for this one, I'm 123.1234. I'm 3.4 away from the line of reflection. So I go 1, 2, 3. Okay. And I do the same thing for A. A is only about 0.8 away. Okay. So this would be C prime now, this would be B prime, and this would be A prime. Okay? And so this is the image after the reflection. Alright, and it's important to keep in mind that the length of this line is the same as the length of this line. The length of this line is the same as the length of this line. And the length of this line is the same as the length of this line. Alright? And then we can write that statement that I was going to put on the front. So a reflection in line K of the pre-image triangle ABC equals triangle A prime, B prime, C prime. Okay? So that's good enough for the first card about line reflections. There's going to be a couple of them. So we're on 133 now. A line reflection creates a figure that is congruent to the original figure and is called an isometry. And an isometry is a transformation that preserves length. So in other words, the length doesn't change. Since naming or lettering the figure in a reflection requires changing the order of the letters, such as from clockwise to counterclockwise. A reflection is more specifically called an opposite isometry. So it's important to remember that the image is congruent but letters in opposite direction. Okay. So on the back we're going to put the properties preserved or not changing, so that means invariant under a line reflection. So this means what properties are not changing under a line reflection. Alright, so for the properties that are preserved, and the word for that is invariant under a line reflection. The first one is distance, so the distance does not change, right? The lengths of the segments are the same. And the second property that doesn't change is the angle measures. So they remain the same. Number 3, we have parallelism. And what we mean by that is that parallel lines remain parallel. We have collinearity. Points stay on the same lines. And we have midpoint. The midpoints remain the same in each figure. And number 6, so those are the properties that did not change, right? Then we have orientation, which is that the lettering order is not preserved. Order is reversed. Okay. Okay. Let's go to 134, which is another card involving line reflections. So let's first talk about reflecting over the x-axis, which means the x-axis as the line of reflection. When you reflect a point across the x-axis, the x-coordinate remains the same. But the y-coordinate is transformed into its opposite. Okay. So let's see, the reflection of the point x comma y across the x-axis is the point x comma negative y. So there's two ways to show this. You can say P x comma y goes to P prime x comma negative y, or a reflection in the x-axis of x comma y equals x comma negative y. Alright? So let's see. Let's just put a quick example on the other side. We'll try not to make this too detailed. Huh. Alright, so I'm just going to draw, whoops. Let's see, 1, 2, 3, 4, 5, 6. I'm just going to go about 6 in each direction, and this doesn't have to be perfect. It's just giving you a quick example of what this could look like. So let's say we had negative 2, 1, 2, 4, and 4, 2. Alright, so this is negative 2 comma 1, 2, 4, 4, 2. And let's say this is A, B, C. Alright, if we reflect that in the x-axis, then we would get negative 2, negative 1. And 4, negative 2. And 2, negative 4. So A prime would be negative 2, negative 1. B prime is 2, negative 4. and C prime is 4, negative 2. Let's see here. So let's put down here in the bottom corner A, which was negative 2 comma 1, and then B was 2 4, and C was 4 2. And then we got A prime, B prime, and C prime. Negative 2, negative 1, 2, negative 4, 4, negative 2. And that's because a reflection in the x-axis of x comma y. Actually, we could write it that way, but since I use the arrows, I'm going to write it with the P. So the rule is x comma y goes to x comma negative y. Okay? So that's it for that one. Now, we're going to do something similar, but just as important. This is card, that was card 134. This is card 135. So reflecting over the y-axis. The y-axis as the line of reflection. All right. When you reflect a point across the y-axis, the y-coordinate remains the same. But the x-coordinate is transformed into its opposite. So the reflection of the point x comma y across the y-axis is the point negative x comma y. Okay. And we write that as px comma y goes to p prime negative x comma y, or reflection in the y-axis of x comma y equals negative x comma y. Okay, now let's do a quick demonstration of this on the back. I'm going to make this a little more accurate by measuring this time. Just so I get halfway. I'll go from 2 to 6. All right. Let's see if I can do this a certain way here. All right, so what I'm going to do is every 1/4 inch I'm going to put a mark. Do the same thing on this axis. Okay, just going to make those a little bit bigger. Okay, now let's say our first triangle was at 2, 2. 4, 4. And 5, 1. Okay. So this would be A is at 2, 2. B is at 4, 4. And C is at 5, 1. So if we reflect on the y-axis, the x-coordinate changes sign and the y-coordinate stays the same. So this one would become negative 2, 2. This one will become negative 4, 4. And then we would have negative 5. One. So A prime is now negative 2, 2. B prime is negative 4, 4. And C prime is negative 5, 1. So the rule was that x comma y became negative x comma y. So we started with point A, B, and C with coordinates 2, 2, 4, 4, 5, 1, and we changed them all using this rule. And we got an A prime, a B prime, and a C prime. A prime became negative 2, 2, B prime negative 4, 4, C prime negative 5, 1. Okay? So all we did is change the sign of x. Keep in mind that if x was negative here, it would have became positive. This means change the sign of x. Okay. 136. This time we're going to talk about reflecting over the line y equals x. So the line y equals x is the line of reflection. When you reflect a point across the line y equals x, the x-coordinate and the y-coordinate change places. So the reflection of the point x comma y across the line y equals x is the point y comma x. And there's two ways we can write this. We can say that p of x comma y goes to p prime y comma x, or a reflection in the line y equals x of x comma y equals y comma x. Okay, so let's do an example on the back. Again, I'm just marking a point halfway. To help me draw my axes. Okay. So, our pre-image is -4, comma 2. -5, -2. And -3, -1. Now the line y equals x goes through the origin and goes up 1 over 1, up 1 over 1, down 1. So it goes exactly at 45 degrees. It keeps going up 1 over 1 and down 1 to the left 1. So this is the line y equals x. Okay? So we're reflecting in that line. So let's say this is point A, and we said this was -4, comma 2. Let's say B is, we said it was -3, comma -1. And C is -5, comma -2. So, according to our rule, which says that x comma y will become y comma x, we have A, B, and C. We have -4, 2, -3, -1, -5, -2. That turns into A prime, B prime, C prime, which will be 2, -4, -1, -3, -2, -5. Alright? All we did was switch x and y. So A prime is 2, -4. B prime is -1, -3. And C prime is -2, -5. So, we have here A prime, which was 2, -4. This one here is B prime, -1, -3. And then this was C prime, -2, -5. And that is all you need to know about line reflections. Okay? Now we're going to talk about translations. So we're on card 137. Alright, so we're on card 137. We're starting translations now. So a translation slides an object a fixed distance in a given direction. The original object and its translation have the same shape and size and they face in the same direction. A translation creates a figure that is congruent with the original figure and preserves distance or length and orientation. Which is lettering order. So a translation is a direct isometry. Okay. Let's see. So image is congruent and letters in the same direction. And the notation would be translation of A comma B of xy equals x plus A, y plus B. And we'll see an example of that later on. So, if we want to draw a picture of this, we could do let's see. So this is the pre-image, and this is the image. And what happens is this thing slides. Okay? Let's see. Let's do the next card. This was 137. So let's list the properties that are preserved or invariant under a translation. First, we have distance. Lengths of segments are the same. Then we have angle measures. Remain the same. Then we have parallelism. Parallel lines remain parallel. Then we have collinearity. Points stay on the same lines. Then we have midpoint. Midpoints remain the same in each figure. And then 6, we have orientation. Lettering order remains the same. All right. Let's see. Okay. On the back of this, let's do an example of a translation. Alright, so let's say this is our pre-image, right? We got A, B, C, and D. A is at 2, 4. B is at 4, 4. C is at 5, 2. And D is at 2, 1. Okay? And let's see that the translation that we do is 7 units left and 3 units down. So we're going to move D 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Seven units to the left and 3 down would bring this to -2, -1. Seven to the left and 3 down would bring this to -5, 1. Alright, so I gotta move B also 7 to the left and 3 down, so that'll bring me to -3, 1. So here's what we got. And I'll show you the, the work for this. But as you can see, you don't even need to do algebraic work. You can just move every point 7 to the left and 3 down. So A prime is now at -5, 1. B prime is now at -3, 1. D prime is at -5, -2, and C prime is at -2, -1. Okay. Now let's show the work for this. So first, it could be in it could be written as a description. So let's put that up here. We can just say like 7 units to the left and 3 units down. That's one way to write it, okay? Another thing we can do is what's called mapping. Okay? And this is the way that I'm going to actually show it to you. We have a translation that's telling us to go -7 in the x direction, -3 in the y direction. So that's going to take our points x, y and move them to x minus 7, y minus 3. Because it's x minus a, y minus b, right? If we look on the last card, or x plus a, y plus b, but since it's negative numbers, we're really subtracting. Okay, so this is the formula that I'm using. So if I use that, I had 4 points, right? A, B, C, and D. And they were 2, 4, 4, 4, 5, 2, and 2, 1. And I just do -7 and -3 to each one, and I get my answers. So 2 minus 7 is -5, and 4 minus 3 is 1. 4 minus 7 is -3, and 4 minus 3 is 1. 5 minus 7 is -2, and 2 minus 3 is -1. And 2 minus 7 is -5, and 1 minus 3 is -2. Alright? That's all you got to know for translations. So we're going to go on to the next type of a transformation, which we're going to talk about now. Dilations and similarity. Okay, so we're going to move on to card 139.